Welcome to the Data Future channel. This is Shekhar, and I am a data scientist. In this particular tutorial, we are going to perform the exploratory data analysis on healthcare data. So let's get started. Let's walk through the different steps which we can perform on the data in this process of exploratory data analysis. The first thing is we have to import the required packages for the data manipulation and data sorting, data filtering. Then we have to read the data, which is maybe in the form of CSV file, text file, or Excel sheet. We have to do some basics analysis by just looking at the data. Then we have to check the number of rows and the columns so that we can get the idea about the data set. Then what are the different list of columns? What is the data type of that particular columns? We have to check if there is any duplicate records are there in the data sets. If duplicates presents, then we can delete or drop the duplicate. We have to also check the missing values, and we have to treat these missing values by we can by using two approaches. One is we can drop the missing values by missing values, or we can replace these missing values by using some meaningful values. The next one is we can do the data exploration and visualization. We can visualize the categorical data, we can visualize the numerical data by using a different types of charts. So categorical data we can plot it on the bar chart or pie chart. Numerical data we can see the distribution of the data by using a histogram, KDA plot, or box plot. We can check the what is the correlation among the numerical columns, how these columns are correlated. We can filter the data based on the condition. We can sort the data based on the conditions. We can group the data based on the conditions. We can provide the solution for the business questions. And finally, we summarize the insights from the data from the business perspective. So these are the basic steps we can carry out for the exploratory data analysis. So let's get started. So initially I'm importing these libraries, that is Pandas, NumPy, Matplotlib, Seaborn. And Matplotlib, Seaborn are used for data visualization, and Pandas and NumPy is used for the data manipulation. Okay. Next thing is I am loading the data by using a pd.read underscore csv. PD means Pandas, and I am providing a simply the data file name, which is in the CSV format. I want to see the first 5 rows by using a dot head. So you can see here this is the data of it's kind of healthcare data. Okay, so here you can see there is ID of that particular patient, gender, then age, hypertension. This value is yes no. The heart disease is yes no. Then the ever married. This is also yes no. Work type is private, self, resident type, average glucose level, the BMI, the body mass index, then smoke status, and finally this is the variable or the column stroke where it can predict whether there is the what is the status of heart stroke here for that particular patient. So this is the data which is collected for different patients and their status of stroke, so that if we are having a new data with us, then we can predict what will be the whether that person will suffer a stroke in future or not. Okay, so let's do some basic analysis. We are having what how many rows are by using a dot shape function we can do the this we can check the shape of this data set 5110 rows and 12 columns. Here we can see the list of columns. These are the 10 to 11 columns. Okay, here um, you can see the list of columns. Then we can see the what is the data type of that particular columns. So here id is the integer, then object means it's a categorical column, then float is the numeric column, integer means it's a numeric column again. So we'll get the idea from the dot d types. When you do the dot info function, here you'll get the complete information about the data set. So here df is my data, and here you can see the non-null values. And only you can see here there is some null values are present in the BMI, and these are the data type, and these are the total entries. Okay. Now we have to check whether there is any duplicate records present in the data. So for that, what I am doing, I am using a dot duplicated function. I am applying for this data frame, and using this function I'll get the data which is duplicated. Now it has written nothing, so there are no duplicates present in the data. Then we'll check for the missing values. So here df.isNull.sum will give you the column wise null values. Now only BMI column is having a null values. So we can plot the BMI column only. We can check here on the KDA. It's just like a normally distributed plot, or you can do, because we have to input the data here for the missing values. I want to plot it by using a box also. I'll check the what is the box plot, and there are so many outliers are present, so I can fill it by the mean value. Okay, so I'm inputting the missing values in the BMI column, so I'm selecting this column, and health df BMI dot fill NA. What I'm doing, I'm taking a mean value of this. Okay, so fill in NA and this mean. So I'll show you what is the mean value of this particular column. Is this This is the mean value. I am putting it into filling it into that missing spaces. Okay, so now you can check, and what I'll see, I have to check whether there is still any null values present in the data set or not. We can check. Yes, there are no missing values present. Our data is as is because we have inputted the data. Now we'll do some basic statistics for the numerical column by using a dot describe. So it will give the statistics of numerical column. Our numerical column is ID, but ID is of no use. That will not give you any business idea. So age, here you can see what is the minimum value of age, what is the maximum value, what is mean, median, standard deviation, 25th percentile, 75th percentile. So hypertension and this heart disease are 0 and 1. So they are saying whether there is a hypertension or heart disease. So but we can check it for the this thing, average glucose level and the BMI. So these values you can see, but hypertension, heart disease and stroke are having 0, 1, 0, 1 values. Okay. So yes, we can check the list of columns. Okay, now in that case, the stroke is the main target variable where we can see whether that person is having a stroke or not. Okay, so what I'm doing, I'm converting the stroke column to the categorical one by using yes or no. So yes means one, so one is converted into yes, and no is zero is converted into no. So for that, what I am using, I am taking this column LDF stroke and I applying a lambda function. So x is equal to s if x equal to 1, else no. So I'll show you how my data set is look like earlier. Here dot head, okay, and scroll right. Here the stroke is having 1 1 1 1, right? And now I'm executing this cell where I am applying some sort of logic here, and here you can see yes, 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 right, under the stroke column. So I have converted that column into a numeric one. So again, I need to check how many columns are numeric and how many columns are categorical one. And for that, I am creating a list of numerical column and categorical column by using a df uh, dot select underscore d types and include equal to np dot numbers dot columns. So these columns are the numeric one. Okay. Out of that, ID is not important. Hypertension and diseases are 0101, just like a stroke. So you can again convert this into a categorical one, no issues. But yes, for categorical, again, I am using a exclude. Instead of include, you can do the exclude here, and you can check the gender, um, ever married, work type, resident types, smoking status, and stroke. These are the six columns are the categorical one. So we'll do some plotting on numeric column. So for numeric column, what we can plot a box plot and a histogram, KDA plot. We can check the distribution of these columns. So initially, I will show you for one column how we can plot the this. I am plotting it for gender actually. So health df, and I am using a gender column here. Gender. Okay, sorry, gender, and I'll do dot plot here. Gender is value count we have to do. No, no, numeric column we have said. Okay, so health underscore df. What is the numeric column? Numeric column is age. I am taking age here. Okay, dot plot, and what is I have to give the kind is equal to box. I'm using this as here, yes, using inbuilt library, that is dot plot in the pandas. But here I'm using this SNS library and plotting for these five numeric values. This is 1, 2, 3, 4, 5. Okay, 5, and these are the numeric column, and I am selecting. So here you can see the numeric columns are this, but I am not plotting for ID. I am plotting for age, habitation, average glucose level, and the BMI. And for that, I am creating simultaneously plotting simple 5 surplus in 5 columns. Okay, and for that, I am using this line of code to execute this. But again, you can see age, average glucose level, and BMI are plotted nicely. But this hypertension and this heart disease is 00101. So again, you can skip these two these things. But here you can for age, average glucose level, and BMI you can see here directly. Okay. There are outliers present in the average glucose level and the BMI. Yes. Now, next one is Numeric column, we can plot the histogram. You can see for the age, I am plotting the histogram here. Yes, plt dot hist, we can give the column name here, and you will see the nice histogram. So the distribution of ages in the different bins. Okay, so I'm using the same function, but I'm putting the all the numeric column here, and so that we can plot this histogram simultaneously. Okay, so I have to again use here one, two, because one is ID, right? So I don't want to plot it for the IDs. Yes, for age you can see hypertension. You will see two graph only because it's not distribution, and heart disease is same case. Average glucose level you can see mostly the most of the records are they are present in the around 100. The BMI is around 25 to 30. You will get maximum frequency. Okay, this is about the histogram, and then we can check the correlation among these numeric variables, and for that I have to select these numeric variables. But yes, these numeric variable I will select here, and I'll put these values here itself. Okay, and okay, and I'm using a dot core function, so it will give the correlation. So how these are the correlated? Means hypertension and age is 27% correlated. This is 26% correlated. There is no variable is correlated here in this data set. So that is fine. So you can visualize this by using this plot, a heat map, by using a heat map in the SNS, and for that I have to save it in the core matrix. I will say core matrix, and you have to run this, and let me just copy this core matrix so you can visualize this matrix, but you have to show it here. Core matrix I'm considering here, a note is equal to true, so you can see there is a nice heat map. So the white will show you the correlated one, but these are the age to age is 100% correlated, but there is a no any significant correlation among these variables numerically. Next comes to a categorical variables. So what are the categorical variables? I will take a categorical variable list of categorical variables here. Cat columns. So I'm taking the cat columns here. Okay, and run this. This is one. So I'm initially taking a stroke here, and I will check yes. So the data is present with no, means there is a no stroke for 4861 records, means for the patients, and stroke is for almost 249 the patients is suffering the stroke. So I will plot it on um, the count plot also, and for that what I need to do is I will put that stroke here. Okay, so or simply you can do it like this. You select this value count and put it here, and simply you just plot and you have to select what kind of the graph you want to plot, and here is the bar one. So you can see there is a nice visualization. So no category means patient with no stroke is having maximum 4861 records, and yes, category is 249 only. Okay, that's fine. So you can do it for by using a matplotlib. So I'm selecting here the figure size and health df, and I'm using the same thing, but let's modify this by using our standard this thing. uh, okay, so here I'm using value count plot kind is equal to same. Okay, this is for gender. So these many things are there. So if you want to just if you want to plot it by the values also, here you just have to put this line of code the for I in the x containers and ax dot bar underscore label and I. You can see x is not defined. Okay, so we have to define here ax. Okay, you can see the values on this. Okay, so 2994 is for female, 2115 for male, and 1 is for other. Okay, fine, that's good. So we can run the for loop and we can plot it all these graphs, bar plot for each category. You can see this is for gender, this is for ever married, yes or no. This is for private job 2925, self-employed, children, government job, never worked. These are the categories under the work type. Resident type is urban or rural. Then this is the smoking status, never smoked, unknown, formerly smoked or smokes, and this is the stroke, yes or no. So this is the nice visualization of categorical variables using a bar plot. We want to check what is the minimum and maximum age in this data set. So it's 82 by using a dot max, and next one is you can see the data set of that maximum weight here, and um, okay, so this is data of age 82. You can see there are so many records are there for this. I'm putting the condition for maximum age. So you can see the minimum age. I'm putting the minimum age. What is the minimum age? Zero point 0.08 years, and I'm checking for this. I'm having the two records where there is a age is 0.08, and this is the data. So next thing is I want to create a new derived column that is age group. So the age group will start from when the age is less than 20. It's age group 1, then 20 to 31, 31 to 40, something like this, and more than 80. And for that I'm creating this new function, that is if age is lesser than or equal to 10, then I have to return is less than 20 a new column. If it is greater than or less than 30, less than 20 and less than 30, then it's a 21 to 30. The same case I am putting these conditions and returning this age group. Okay, and I have to run this. Now I have to apply this to the age column of the health data. I'm applying by using a lambda x and get age group. That function I am applying is x, and I'm going to create a new column that is the age group. When I run this, now you can see here there may be a, at the last you can see there is a age group. This is the age group. So you will get this age group, so you can derive the columns also. I want to check the data, how this data is distributed among the age groups by using the same value count plot data kind bar. So most of the data is available for less than 20 years. Then this is 51 to 60, then 41 to, and only the more than 80 years olds are 116 people or the patients. Okay, so this is the distribution of the data age wise. We can do the analysis according to this age groups. So here you can see we can take the age group by the age group, and what I want to see how many strokes are their the values. Okay, so I'm using a group by to group by on the basis of age group, and I'm checking how many are getting the yes or no. Okay, so this will not give because I'm using here I'm using here some that is wrong actually. So what I want to do is it's let me check how we can do that here, but we can skip it now. We can check it for the gender, BMI and age group, and what I want a mean value of this for for this gender. Instead of that, I'll check it for different age groups. Okay, for age groups. So, and we can do it later on for this uh, for this other categorical column. So when you do that, so you can see here I'm doing the group wise aggregation, and for 21 to 30 you can see the average value of BMI, glucose level, and the age is 25. Okay, yes, obviously that age will be also the same, but um, you can see the average value is here 8, and what is the average glucose level here. The same thing you can do it for strokes. We can check what is the average values of this numeric column. Okay, then average value you can check here. For no, it's BMI is 28, average glucose level is 104, and age is 41. But those patients who are suffering from the heart stroke is having BMI more than 30, average glucose level is 132, and age group is 67. So you will get the idea from which patients are directly suffering with this stroke from this. Okay, we can check it for ever married here, and we can do it by, okay, ever married, and the same thing we can do it for if ever married is this, then these are the average values. If yes, then for work type we can check what is the value of this. So most of the cases here you can see the self-employed is having the more number because BMI is greater, this average glucose level is high for the self-employed people, and age is also in the average age is 60 actually. The resident type, what is the effect of resident type here? So resident type is, I think there is a no any such effect on these values. You can see average values are almost same. We can check for smoking status. Smoking status is smokes are when the formerly smoked are having these maximum values, and smokes are having, you can say, these are the values, means there is a quite effect on this on the BMI, average glucose level, and age. Stroke we have done. We can do it for the gender here. We can do it for gender, and for gender you can see female, male. Males are having a more glucose level, and average age of female is greater in this case. Okay, that's fine. Okay, now now we can group by it by using the gender and stroke. Okay, here. So for that, what you have to do? Yes, for no and yes. So you can do it here. Likewise, you can aggregate by using a two categories, stroke and gender, by using a average glucose level. You can do it for this stroke and this thing here by using this average glucose level. You can check stroke and work level also. You can check. Okay, and stroke and residence. You can do the this thing, and stroke and ever married. You can check the average glucose level. So correlation matrix already we have seen here, but we can check the how they are correlated. Already we have seen, but we have to check the scatter plot. We will plot the scatter plot here, and for that I'm using a parity.scatter, health, age, health, average glucose level. I'm putting age versus average glucose level. So you can see this is the plot of age versus average glucose level. This is age versus BMI, so I'm doing the same, age versus BMI, and finally it's average glucose level and BMI. I'll use this thing. So there is a no any correlation among these variables, but based on the different aspects of the attributes of patients, we can check how the effect on their the heart level. Okay, so this is all about the complete exploratory data analysis of the data. So on top of that, we can build the hard stroke prediction machine learning model based on this data. And I'll come up with the new session where I'm explaining how we can predict the heart stroke by using this data, so that if you give your details or the patient's details, then we can predict whether that person will suffer with the heart stroke in future or not. So this is all about the exploratory data analysis on the healthcare data or the stroke data. Um, Thank you. Thanks a lot.